надеюсь, что все, кто хотели.
Well, I hope that everyone who wanted to scan the QR code did that. Let's kick off this part of the session. We'll be talking about sandboxes and the way you can evade sandboxes. However, before we do that, let me introduce ourselves. My name is Vladislav Azersky. I'm a information security leading expert in F.A.C.T, and my co-author is Isaev Alexander, who is a viral analyst in the BI.ZONE. Let's start with the basics. What is a sandbox? Let me just brief you on how we came up with the idea of this presentation. It's very simple and easy. We took a close look at various articles and researchers about antiviral bypass ADRs, but for some reason everyone tends to forget about the sandboxes. So we decided to deliver what I hope is going to be an interesting presentation. But let's define a sandbox. What is a sandbox? A sandbox is a proactive protection tool that allows us to implement suspicious files and scripts in an isolated environment. And even if you do various pen tests, oftentimes you don't need to bypass sandboxes. You can come across them as part of an email solution. And a phish app will be analyzed by a sandbox, and it will say that something suspicious happened. As of the present time, there are various Cuckoo sandboxes, Cape version 2, which is a branch of the Cuckoo sandbox, Dark Poof, and so on and so forth. These are the sandboxes that you can use in your daily activities. In addition to that, there are cloud-based sandboxes, such as AnyDex, Hybrid Analysis, GeoSandbox, Sandbox, and others. Moreover, there are corporate solutions, and the specifics are as follows. They are used for the email security and analyzing traffic files and drawing a conclusion or a verdict. Our analysis is primarily based on a large number of hosts that we got triages from. We did compromise assessment, and we have a huge pool of data about the hosts, about the way hosts of ordinary staff work. We took 4 sandboxes. Of course, we're not going to name the vendors. We will just number them from 1 to 4. So without further ado, let me move on to the main part of my presentation. And I'd like to brief you on the main techniques that we singled out. Right. Most of the time I do forensics, therefore it's interesting for me to take a look at various artifacts that might be useful. The first technique boils down to the following. You can identify the total number of launched or implemented specific programs and their components, and this could be one of the criteria. I mean, the file launched is working on a desktop of an employee. The prefetch files, let me just remind you what it is all about. It's one of the Windows subsystems that boosts the performance of the system by preloading the code of frequently used programs. You can go to the CS Windows prefetch, and you'll see lots of files with the name of the file and then a hash. And inside you'll find lots of useful information. For instance, the number of launches of the Office or MS Word, the time tag of the latest launch, and Windows 11 and up will show you the 8 most recent time tags, and the user who got access to the launched file. There are two main criteria that will help you. The number of launches of a specific program and the time tags. You can use them if the VM of a sandbox and a physical desktop are alike.
Пошел следующим образом, посмотрел, а какие...
So my approach would be to take a look at what are the most frequently used files or programs. And of course that's MS Office apps such as Word, Excel, PowerPoint, and so on. In other words, the digital paperwork apps that are most frequently used by organizations. The next bullet would be various web browsers, messengers, and communications means, as well as mailing clients, email clients. You cannot collaborate with someone without communicating with them. And the last category are the Windows system components, such as Explorer, which is responsible for the desk task manager, and it will be launched several times when you log in onto the Windows. The last one is the login UI. And you might remember that the WinLogon is responsible for launching the login UI that provides the user interface for typing the login password and authentication data. So an employee will use this app at least several times when he types in his login and password in the relevant fields. As an example, we decided to describe the following situation. Let's say you have a sandbox and a physical machine. It might be a VM, it's just a desktop or a laptop or of an employee. As you can see, there is a huge difference between the total number of launched apps. In the sandbox, you see MSH, Chrome, and Firefox. The sandbox image preloaded Firefox and Chrome. They were launched for a limited number of times, and naturally that was part of the activities of an employee. However, if you take a look at the real cases with the activities of the employee, you'll see that he will use email clients, not just web browsers. And what's even more important, the sandbox never mentions Explorer, but it mentions login UI 4. Which is insignificant because if you use host on a daily basis, this count will drastically increase in the prefetch file. So the case I described is true for sandbox too, because at least we have some records. In the other three sandboxes, we didn't have any information on login UI or Explorer. In the we saw that the browsers were launched for a couple of times, which means that the file executed operated in the sandbox. The next technique is closely linked to the first one, and it's about the Office documents. In the Windows OS, there are at least two sources of artifacts that will help us analyze what happened to the documents. For instance, you can go to Trust Records in the user registry, and there you'll see whether a user edited any of the documents or launched any macroses. The pop-up yellow window, if you want to launch a fish, will be an obvious sign. And if we analyze
В рамках примера здесь мы можем увидеть, опять же,
We're going to see the following. As you can see, the sandbox is on the left-hand side, and the desktop of an employee or a physical machine is on the right-hand side.
маленькое количество событий.
In the sandbox, we have very few events, and they're spread apart significantly from 2018 to 2022, which means that this host probably was not used for work. And trust records are non-existent, which is funny, because when we send each other various documents, we launch some macros or edit documents. And the physical machine shows that the employee was active. He searched for various documents. These are the alert logs in the Windows when you use Microsoft Office software.
Закрываем приложение, оно нам...
When you shut down an app, you get a notification that you need to save your document, and it goes to the alerts log as well. So ultimately, all the 4 sandboxes that we analyzed demonstrated that there were no trust records per se. And even if alert logs had any records, they only recorded 5 to 6 events. The next technique is an arguable one, because you have to take into account specific departments of the employees. For instance, a financial department or a legal department who tend to print out lots of hard copies. In that case, it could be used. So, if you analyze the sandbox, you'll see that the number of records of printers used for printing out hard copies, there were just 4 or 5 of them, which is suspicious. By default, the number coincides. Let me proceed to the next slide. So, like I said, 4 to 5 default values are shown in the registry, and if you deep dive into a desktop of an employee in a legal department, for instance, you'll see lots of records showing the names of printers, their IP addresses, or even proprietary names. We did not research that, but I think it would still be interesting. So the conclusion is as follows. In all the sandboxes, we would see 4 to 5 default values, and only in the physical machine we're gonna see additional records showing things like an IP address, and we will see at least 6+ records. If there are 12 to 20 of them, then we can assume that it's a physical machine used by an employee. Another interesting thing that I want to mention is the desktop screen locking and unlocking. We can show the entire sandbox workflow. It deploys the golden image that has been fine-tuned and set up, or will be set up later on, and we're not going to come across desktop screen locking or unlocking because it doesn't make any sense. But we can go to the window when log on operational. However, it's very difficult to interpret these 2 screenshots, because it says well, we get an SRV value, and 4 and 5 are the identification numbers. We had to go to Wing logon to analyze it in depth, and the reverse engineering led us to believe that 4 stands for blocking of the desktop screen, while 5 stands for unlocking. And if you run this test by rule of thumb, this is the way it's going to look. 4624 event is a specific login type linked with the unlocking of the desktop screen. However, it does not work the way we want it. ultimately, what we get is as follows.
Источницах у нас ситуация, вообще события, блокировки.
In all the sandboxes, we did not see desktop screen locking and unlocking events, while it should at least be possible for a couple of times per day for an ordinary user.
И вот по результату мы видим как раз
And these are the results showing a very sad situation. As for event 812 and the SRV events and events 4 and 5 are 0, though in a physical host their number will exceed 10.
вот эти 4 техники, они в основном
The first 4 techniques are based on the user activities. In other words, when people had to do something, launch some files, and work with documents. But now let me move on to 2 other techniques that can be analyzed when a VM machine is started up in a sandbox. Technique 5 is the system uptime.
жизни, даже не время, а время аптайма, рабочий.
The uptime of a desktop considerably differs from that of a VM in a sandbox, because the desktop might not be switched off for 2 to 3 days, while the VM uptime will last for several seconds, or until a deadline set up by a launch case, for instance, for the file check.
Что разница в рамках
As shown in the slide, the difference between the sandbox and the desktop is now huge. On different days, the VM was launched for several seconds, while the desktop operated for 3 days without any interruption, or for several months. And this is the way to differentiate a sandbox from a desktop.
вот видим такую
The
ситуацию.
results are shown in a slide. In all the sandboxes, all the sandboxes differed from the physical desktops. The first two demonstrated breakup by uptime at 48 and 24 hours, but the last 2 accounted for just 60 seconds of uptime, and I'm talking about all the events. As for the physical desktops, we're talking about days or even weeks, depending on whether a user switches off the host during the daily activities. And the last technique is the time gap. That's the time between the file executed in the sandbox and the previous event. For instance, in Windows, you get such great artifacts as the SRU, which is a resource monitoring, storing the records in a single database. You can log into this database and get info on the previous events that preceded the launch of a file, and you can use filters to identify its name. Another interesting artifact is the SM journal. It's NTFS file system. You can see what files were changed, what files were deleted, what files were removed, and it's another good criteria, because if the file executed was copied onto the host and then moved somewhere, you can use the preceding event to see the location, especially if it was done 2 weeks ago. But you need to have admin rights to deep dive into the RC journal, and you have to use utilities to copy it into a file system, then break it down and identify the time gap. And the same thing is happening with the database, but you need to shut down a server to get hooked to it.
Вот, если на самом деле видно, здесь можно увидеть, что Внизу это у нас все USN Journal.
Shown at the bottom of the slide is the USN journal, and this is the utility to collect data, but we're not concerned about it this time.
А в рамках SRU, то есть монитора
The SRU, which is used for resource monitoring, shows no activities which should be somewhere here. Even if it happened, the table was not populated. As you can see, the data is different.
что разница
So the difference between a sandbox with the difference in the sandbox could be considerable and total 5 to 8 days. While in a physical desktop, if a user opens up, launches a file, the difference is not going to be as pronounced. It's going to be less than 8 hours. This is the end of my part of the presentation. Now I am going to pass on the floor to Alexander Isaev for his part. Hi, everyone. I just wanted to thank everyone for coming here to listen to our presentation about the sandboxes. I believe that there are very few presentations like that, though they are in demand. So I'll walk you through the second part of the presentation. I'll talk about the graphic evasion concept. I'll tell you why it could be useful and what it is an alternative for. I will also brief you on my techniques that have been tested, and they demonstrated good evasive capabilities as far as the sandboxes we analyzed are concerned. I will also share with you the overall outcomes of evasion techniques demonstrated to you by Vladislav and myself, and then I will sum up the results, and we'll try to save some time for the Q&A. Let me ask the audience the following question. Please raise your hand if you know what this means.
Ну, приятно. А если есть возможность такая техническая, можно кому-то...
That's great. Could you please bring a roving mic to any of the volunteers who'd like to tell what that is? Please bring a mic to someone who raised his or her hand. Is it a bully pyramid? Indeed, it's a bully pyramid. If you don't know what it is, let me brief you on that. It's a bully pyramid, and threat hunting and threat intelligence experts use it from time to time. The main point is as follows. There is an attacker, and they have a certain kill chain. It's a staged sequence of activities to launch an attack to reach a certain goal. And the kill chain features certain characteristics which could be large or small. And this pyramid shows hash IP addresses, domain names, and network artifacts, tools, and techniques and procedures. I think this pyramid is interesting because the elements shown in the pyramid follow a certain sequence and are characterized by certain parameters. I call them pinpoints in a humorous way, but you can interpret it in the following way. The difficulties that an attacker will come across in changing an artifact or an element if something is blocked. In other words, if someone blocks a file through a hash, we all know that most of the hashing algorithms, such as ND5, SHA, have a waterfall effect. So a hash will embrace a different value, which would be totally different from the previous one. As for domain names, you can register fake domain names in advance, so it's not going to be a problem for you. However, if you're blocked by tools or tactics, techniques, and procedures, then it is going to be way more tougher. In other words, it's still doable, but you will spend more time on thinking how to bypass that. I did not show this pyramid by chance. I will get back to it because my presentation is about evading sandboxes. So what we see here is the Sorny mem and the meter classification on sandbox evasion. It's simple, it's useful. There are three categories: system checks, user activity-based checks, and time-based evasion. In other words, attacks linked to time in some way. However, what I did not like is that it does not show any characteristics in terms of the level of difficulty, abstraction, execution of or implementation of the code for evading. And unlike the previous pyramid, this classification has no characteristics. It just shows the breakup by categories and techniques. This is it. Unless, of course, you try to zoom into every bullet. So my concept is an alternative. I'm not saying that we need to forget about Mitra matrix. It's a well-known matrix recognized by everyone, but I'm proposing an alternative that you still can use. So this is a simple pyramid, and let me explain to you what you are saying. It's not by chance that parts of the pyramid are of different thickness. So the main idea is as follows. I took all the evasion techniques and divided them into three categories: high, medium, and low. As for the characteristics that are linked to these categories, well, they're as follows. The abstraction level of the code and the popularity. Up top, you see the highest abstract techniques, which are the most popular.
Соответственно, это я привел некоторую аналогию с
And it is similar to the programming languages. If you're a programmer, you might have come across the high-level and low-level programming languages such as Java, and Ascender is the low-level programming language. So the structure is similar. As for the popularity, these are techniques that are linked to small-scale detects, such as a key file or a register file, and they are more popular than more complex techniques with machine code fragments and low-level stuff. And simplicity is just the opposite. The lower the level, the more difficult it's going to be to implement this type of evasion. Up top, well, by the way, it is true not just for the sandboxes, but also for virtual machines such as VirtualBox, VMware systems and subsystems. Most of the sandboxes, by the way, are based on some the virtual machines at the lowest level. As for the highest level, we're talking about registry keys, files, and so on and so forth. These are individual artifacts. You can single out a couple of them and start an evasion. The medium level, we're talking about larger stuff such as OS build version. It might not be the best example, but it could be a complex fingerprint of the software installed in the sandbox, or hook key injections in the sandbox. And the lowest level is the lowest level of abstraction linked to the machine code execution and specific characteristics of a virtual system. Well, you can come across various examples at the highest level. In addition to sandboxes, you can use AVM.
It's not a secret that there are many evasion techniques that are based on register key sticking out somewhere, or a file name, or a disk name, or plugins that shouldn't be present in real physical systems, something. Mid-level, you can come up with your own examples. Low level, from my experience, I'd say Gloda. If you don't know, Gloater is an invasive load. Its objective is to load other malware. In addition to loading other malware, it also evades sandboxes and VMs. It consists of several code fragments that execute the commands. And the most remarkable feature is using RTSC instruction in the assembler. This instruction actually counts the number of cycles after the processor zeroing down, because these counters are very different on the VMs, on sandboxes, and physical machines. So if you run many RTSC instructions and then you count all these total values, you run them 10,000 times, 1,000,000 times, you will see big differences between what a sandbox shows you and what say physical machine shows you. So this is a low level in terms of abstraction, and it's not very popular. The glory techniques were known or have been around for a long time, but it's not like we observe them in action many times a year. But it's an option. So I'm done with the concept. It's just the alternative. I'm not saying that this is better than Mitre or that Mitre is bad, but no, you can use this in addition to whatever you are using yourself. And now let's turn to the techniques, to my own set of techniques. The first one, well, it's numbered 7 here, but it's the first one in my part of the presentation. It's the network uptime. If you've ever been in this business or read about it, you know that uptime can be measured in many different ways. You can do as Vlad, using logs. You can measure, well, up to you. You can count the process explorer duration or the process code, or that starts in the user mode after you initialize the Windows nucleus or something else. Anyway, I decided to take the network uptime just to be a bit more original. I would like to thank the manufacturer or the vendor of this well-known system. This we can still squeeze something out of it. We can check which network uptime the VMs and the physical machines produce, and we compare these two values. These are the results that you get in the physical machine. There, the uptime can be, well, it can be anything, really. When we triaged from the corporate networks where you have big clusters of machines, and uptime can be quite high. Usually it measures in days or weeks, sometimes even months. 2 other sandboxes, number 3 and 4, they show comparable results. This evasion technique works 50-50. So I wanted to share with you the most efficient techniques, but I decided to keep this one as an example, just, you know, to calibrate the techniques so that you would see that in terms of sandbox evasion, not all techniques are perfect. The first sandbox showed an intermediate result. It's not like it is an outlier, but the numbers are always within 15, 20, 24, 26 minutes. I don't think I ever saw more than 26 minutes, so this is the range. It's 50-50, up to you. You want to play with it, just go ahead. The second sandbox, well, you saw the numbers yourself. Recycle bin in the well-known operating system, the good old recycle bin. I use COM objects interface shell 32. You get several lines of code on shop. You run them. You get the files out of the recycle bin. The recycle bin, it's a storage of files where there's a lot of work going on. All the waste goes into the recycle bin, usually all the outdated documents. So probably you know that in big offices where people are busy, recycle bins are usually not empty. Yes, there is automatic cleaning of the recycle bin. Yes, you can remove files manually, but I do not remember many corporate users who would, on every Monday at 7 o'clock in the morning, would clean the files from the recycle bin. One of the simplest techniques that works on the recycle bin is described here. So in none of these sandboxes, in none of these recycle bins, not a single file was stored. In the series of hundreds and thousands of runs, initializations, nothing. I was confused. It was very difficult to believe that this simplest thing can be used as a certain technique or a certain method of evasion.
Девятая техника, значит, здесь о чем у нас идет речь?
Technique number 9.
Windows 10,
Windows 10 and 11, the latest versions of Windows, offer, well, it's not like they offer, but they have this function. It's called feature usage. And it's got something special built in. This OS collects statistics. It collects stats on different actions in the file explorer, like the buttons you press or the interface elements you engage. So it tracks the functionality. You go into the register, I can give you a complete passage, key, current user, software, Microsoft, Windows, current version, Explorer, feature usage, trade button, click, start button. This technique is all about the fact how many times the start button was pressed throughout the time that this operating system was in operation. So just one key of the register gives you this information, how many times the OS was started. The result is totally unsatisfactory for me as a security guy. Physical machine, more than 10 times the button pressed. They're the freshest machines, you know, the ones that were in use for just a couple of days. Most of the machines in the triages, they were looking at 3, 5, several thousand pushes of this button that are made in the years that the system was used. They are not some special sandboxes. They are used to build commercial sandboxes, but you can see the results yourselves, right? Another case very close to the earlier one, in this case we have the search box. What's search box? Next to the on the task bar, you will also find this search bar, basically, and it's the same technique. Go to the same register, same area, and you read not the start button click, but trade button click, search box. You look for search box. People usually in Windows 10 or 11, they do search for something on their computers. So this is the technique, and these are the results. These are two examples from the same category. They are very close technically speaking. And it's complete evasion, you see. And on the physical machine, again, more than 10. The median is depending again on how long the OS was in use. Like for the start button, it was 800,000. With the search, 1,500. Well, anyway, we are looking here at hundreds, dozens at least. The sandboxes have nothing. And one last example. I tried to combine it a little bit of forensic artifacts. I decided not to split them by technique because I looked at the numbers and statistics. What I'm facing here, it turns out that the results are good when you combine 3 techniques as one, when you do not split them and do not run them one by one. MRU, most recent use, right? That's the acronym. File objects, programs, sometimes recent docs means recent documents. Word wheel query is the parameter that is responsible for storing the list of search queries that you made in the Explorer window. It's not the same as the File Explorer that you get next to the Start button, but usually it's in the File Explorer, somewhere to the in the right top corner. So these three techniques combined together is what I call another system activity. And we are looking again at the register and the user in the Explorer, and these are the results. In the sandbox number 1, a good number of recent, but this recent is quite old, very small, very low MRU, not typical of real machines. The second sandbox, a lot of recent, but others run MRU, for instance, very low. Sandbox 3, everything low, with huge divergence of dates. 3 years ago, we had something. 2 years ago, nothing. A year ago, it looks like suddenly the computer was taken off the shelf and was put into use. Doesn't look like a real machine. Sandbox 4, no recent. Very little. It's like the machine was in use for a couple of days. And then if you correlate it potentially with the date of installation, it was installed 4 years ago, but it feels like with the percentage of activity, there's a mismatch between that date and the usage period. The physical machines, depending on how old they were, they looked quite adequate. There was a good match to our criteria. The numbers looked quite realistic, not like sandboxes. So that's Vlad's part. These are his techniques. The green here shows the places. Well, if evasion would not be possible with this technique, it would be colored green. Yellow is a 50-50 technique. You can take into account it's not perfect, but you can combine it with something else. Red means this is total evasion of the sandbox. You can use this technique for evasion. So you see here the results. These are Vlad's techniques, and these are my techniques, slightly different. My first technique that I demonstrated, if you remember it, the network uptime. The sandbox looked a little bit like real machines. Everything else, well, you can see with your own eyes. Now, let's draw the line to this presentation. Well, it would be great if more attention would be paid to sandboxes as a means of security, like Vlad said. Everyone talks about evasion of antiviruses, ADR, and other systems and sandboxes. I'm not saying like everyone ignores them, but it would be great if sandboxes were used more actively. There are so many bypassing techniques. The number is huge. Only your imagination is the limit. Your knowledge of specific sandbox or class of sandboxes, and basically your knowledge and your imagination are the only limits. And you can come up with 100 or 200 different evasion techniques. And the third point here, never settle on just one option. I've demonstrated the techniques one by one, but in fact, the idea is for you not to use just one single technique. Take technique 2, 5, 7, 9 and combine them and test them and put them into bundles. If you want to build evasion that would work well with commercial sandbox and open source sandboxes, you'll have to combine techniques and not to get fixed on just one option. And by the way, with respect to files, number of files, dates. Use different characteristics, not just the number of files, but also the dates and the date ranges. What's the date interval where you have files, and what's the date interval that you don't have files? Are there any gaps between the dates? Try to trace some systemic parameters. Look at the deleted files. Look at other places in the system where you can get information to match it against what you saw here. So that's it, basically. And now it's time for questions and answers. Thank you for listening. We were happy to share.